All right, hello. So we're back again. We're gonna work on oh, why is that not erasing? All right, so we're gonna work on question number 6. So this one is a bioavailability question, and it's trying to find the relative bioavailability of a new drug product compared to a marketed brand name product. Talmasart, yeah. Okay. Um, I don't pronounce drug names right at all, so I try to avoid it at all costs. So, with this one, what equation we're going to use is this one, not that one. So we're going to find they already found the area over the curve and the dose for us, which is terribly convenient. So, for the first new drug product, which is the one that we are comparing to the standard, brand name is always the standard that we're usually comparing to. The reason this being is that according to the FDA, a generic drug is allowed to, I believe, have 6% variability. So if they have more than 6%, then that's an issue. So we take the area under the curve for the generic drug and we normalize it over its dosage. So this is going to be a dosage normalized. All right, so then that's the first ratio, and then we do the second one. And that's dose normalized as well. Now, why do we dose normalize? If you guys paid attention in class, dose normalization, the reason you do it is because area under the curve is the activity of the total drug. That's all the drug. So, of course, when you give more milligrams and you're trying to get the same amount of activity as, say, an IV, the activity may be the same, but the amount of dosage might be different. So you're trying to find the efficiency of that drug, possibly compared to the standard. So when you guys divided this, it was 101, when you just divided this straight off, so if you multiplied that by 100, you would have found that that was 101.77% bioavailability. Now, how do you have this happen? There are two different ways that this can happen with a generic drug especially. So the first thing that comes to mind with me is that there is a racemic mixture. That means that there is an L form and a D form of this drug. And so possibly the L form or the D form is the one that we're testing, but when they process this drug, they try to get rid of all of the other form that we don't want, but when the generic process it, it's a cheaper manufacturing process. Sometimes that slips through and you end up with the bioactivity from the other form that's not supposed to be there. So that's one way that you can get over 100%. The other way is that it gets absorbed back into the system, and that's another way that you can have over 100%. So when it's supposed to be excreted, it gets absorbed. I'm trying to think of another reason. The last reason I can think of this possibly happening is, no, that wouldn't work. No, I was gonna say it's metabolism, but that doesn't make any sense, because when you have a prodrug and you metabolize it into the actual drug, you're still getting the same availability. So why would this be necessarily a bad thing for the generic drug company? Why would this be a bad thing? Your drug is having a better activity than the brand name. Well, if it's an L and a D form and you don't want the L form, let's say in this drug hypothetically, and you only want the D form, let's say the L form, not only does it cause bio extra activity, but it could cause issues with side effects, toxicity, which is what I used to study. I'm a toxicologist, so this might be a concern if that's the issue. So just keep that in mind, that there are reasons for this happening. Now, in regards to the exam, I told people during class that it was very rare to get over 100%. And Tolman's eyes peaked up as I was saying this in the front of the class, and I sit in the front of the class, right in front of Tolman. So I kind of feel like this was partially my fault, and I think that professors just want to test your limits and see if you really understand the concept. Did you understand that you were supposed to find the generic over the brand name and not necessarily look for an answer that was less than 100%? I feel bad if anybody lost points due to me. I feel really bad about that, but I hope you got the concept. Most of the people who sit in the front anyway seem to do really well on this exam, so because we go to class and we pay attention. But if you're distance student, I'm sorry you guys didn't expect this, but you guys weren't prepared to find an answer that was below 100%. So don't worry about it. You guys probably did it right. All right. So that is it for question 6. We can go through the multiple choice, but I don't feel like it. You guys have the answer key. The matching, if you already... So the thing with this exam was that this matching, the only ones... Use the exam to your benefit. So the only one that you didn't have in the exams that was not in previously, like AUC, you could have looked back and gone, yeah, it's milligrams per hour per milliliter. So you go down and you go, oh yeah, that's K. All right, so you just use the exam. Oh, clearance. What's clearance? Oh, I used clearance back here. Oh, clearance was liters per hour. So it's F. It's just use the exam to your benefit. Don't necessarily have to memorize these. The only ones that you had to memorize were the rate of elimination, not just RO is the rate of infusion, but the rate of elimination, which has the same exact units as rate of infusion, because they're related in the system we're studying. So we had the rate of infusion, the rate of elimination. These are comparable objects. FE, what was FE? It's a percentage of some sort, if I remember correctly. Oh, I knew it for the exam. I memorized that for the exam, but now that's the only one that I'm looking back on that I cannot remember for the life of me. But you can't pull those from the exam, but you should have gotten, out of the 10, you should have gotten 8 right if you had done the problems correctly. And if you remember the other ones, good for you. You have a stellar memory. I'm jealous. Then you had the 5 true-false questions, which, I mean, we have the answer key. You can go look through it later. This one, the true-falses were all pulled from the notes, so you can find them all in the notes eventually. But this one, I want to go over real quick. So, this is your concentration steady state. So what is your concentration steady state? It doesn't have an accumulation factor and it doesn't have an elimination factor. So number 2 has an accumulation factor. So what part? So this is the accumulation factor and this is the elimination factor. I should do that in a different color. Let me do that in a different color. So here's the elimination factor. What part of this equation on this chart is there elimination happening? The elimination is happening here. So just because you see this, you automatically know that that's going to be C, because that's elimination. What part is concentration steady state? Well, concentration steady state is right where it's flat. That's right here. So that one is going to be B. Well, where is, for the last one, even though we have it set up, which one is just looking at the accumulation? Which one is just looking at the point to seeing where drug is building up? That one's going to be A. So that's this point right here. So this was more of a question of, do you understand what is going on when you're entering an equation? Can you think of the I am lost for words. Can you think of what the numbers represent? What is the reality of the numbers? Which, if you ever take a business accounting class, numbers are equal to reality. So for 24, 25, and 26. All right. So I'm just going to go quickly through these just because they're very simple as well. So this is a relation to ADME, which is absorption, distribution, metabolism, excretion. So in our one compartment model, we don't have distribution at all, but we do have absorption. So that is RO into our one compartment model, and we have elimination. So our elimination is just metabolism and excretion. So that's our elimination. So it asks you which ones compose that. Well, that's going to be metabolism, excretion. So that was a double answer. This one was, could you do math? Very simple math. And I believe the answer was 15.25. I don't have the, actually, haha, I do have that. Yes, it was B. So, it was B. That one's just, can you tell, what part of the equation is that? What time is the infusion run for? So can you read a clock? Which got me particularly miffed, because I think we're pharmacy students. If you can't read a clock, then you aren't showing up to class anyway. So that's just hard on people that don't have clocks and don't show up to class. But it was a give me for almost everyone else. All right, so choose the correct statement regarding steady state. Well, after steady state is reached, the concentration can only change if his infusion is discontinued. That is false. Concentration can change if a bolus dose is given as well. Steady state is equal to the drug elimination and the drug input. Yes, because I drew it up here. I was looking for it. So that one is right.